Good evening. Module 2 Assignment 2. Today we are going to continue the yesterday's problem, that is Module 1 about the pseudocode code. Uh, Today we are going to take an input grid, and the output for today's code is that to pick out a possible value, expected value for each and every square. So in the yesterday's code we have decided how to give the pseudocode input, and we know how to get the squares, the units, and the p value of each and every square in the grid. So now we are going to give an input example for it. The input can be given like this or in this way, where the string of characters 1 to 9 indicate a digit, and a 0 or a decimal point will be specifying an empty square where the expected output should be present. So for that, we have a piece of code which we'll be discussing later, and there are two steps for the called constraint propagation, where how to fill the empty spaces, like the necessary rules, a set of rules actually. So if a square has only one possible value, then eliminate that value from square speeds. Means in the input, for example, we got 4 in A1. So its pairs means A1, A2, A3, A4, the row and the column and the 3 by 3 small grid should not contain another 4. So that's the first rule. And the second rule or suggestion is that if a unit has only one possible place for a value, then put the value there. So maybe if all the elements in the 3 by 3 grid are placed and only one element over here, I mean the last element has to be placed, and in that list of the unit list only one possible element is remaining, then we can directly put that element over here without any further inspection. So these two are the suggestions or constraint propagation rules which help us in completing the code. So this is the code which we are going to study. I have placed the code over here with the yesterday's module 1 code, and so here is the grid example which I have taken. So the 0 represents the empty space, and a digit represents the value in that square. So in the beginning itself, I'm sending the grid to the function parsegrid. So let's see what it's doing. So in parsegrid, I have the grid which I have taken over here. So I'm taking a values variable and assigning all the squares with the digits, like A1 can contain 1, 2, 3, 4, 5, 6, 7, 8, 9. A2 can contain 1 to 9. A3 can contain 1 to 9. So we are doing constraint propagation by eliminating the unnecessary elements or which cannot be placed in that square, and only placing the elements which can be present in that square. So why don't we print the values and check for ourselves. Maybe there is a print statement over here. I'm going to run it again. So this is the final outcome. Before the final outcome, these are the values. See, for A1, we are applying the string 1 to 9. For A2, again 1 to 9. A3, again 1 to 9. So each and every square can have 1 to 9. So we are just assigning it for the presence of it. So we will be removing the unnecessary elements which cannot be placed in the square and only keep the elements which can be present in that square. As you go on with the code, so in the for loop, now I am going to send the grid to the grid values. So what grid value actually does? So here is the grid value function, and now the grid value is actually converting the grid string to a grid characters and placing it in a dictionary. Why don't we print it and see? So the input which I have taken will be getting like this 0 0 3 0 2 0. So a1 is having 0, a2 0, a3 3. This is the input which we have given. The grid is converted into a dictionary, and then I'm with the help of a zip function in dictionary, I'm placing the squares which contains a1, a2, a3 with the necessary characters. So we can print it over here and see. So as I said, is 0 0 3, like a1 is 0, a2 has value 0, a3 with 3. So this is the input which I have taken and converted into the dictionary, and I have assigned to the squares for each and every value as a key value pair. Now I am sending this grid value each and every item. I am rotating in for loop, means S contains a1 and D contains its value 0. So I am sending it. I am making an iteration over there, and then if the D value is in digits, then I'm sending to assign. I'm calling the assign function, which has 3 parameters: the values which I have taken over here, the S and the D which I have got from the grid. So the assign values. Since now we have the value 3 over here, right? In the example. So A3 contains 3, right? When we get 3 over here, I'm calling the assign function, and I'm replacing that 3 with an empty string. Now the other values will be the other possible values in A3. The other values will be 1, 2, 4, 5, 6, 7, 8, 9. So I'm calling the eliminate function for each and every other values. So for 1, 2, 4, 5, 6, 7, 8, 9, we are calling the eliminate function. So the basic thing which the assigning and the eliminate function is doing is that if we have a value present in a square, means A3 is having only 3 as its value, which we got from the input. So the A3 in A3 we have 1 to 9, right? So we will be removing 1, 2, 4, 5, 6, 7, 8, 9 from the A3, and only 3 is placed in it, and 3 is removed from all the all of its pairs. We'll be doing it in assign and the eliminate functions. So if coming to eliminate, if you already eliminated the value from that string, then we are simply returning the value, or else, I mean, the iteration is through other values, right? For 1, 2, 3, for every iteration, eliminate function is called. So for 1, the first one, it will be replaced. The 1 is replaced with so the 1 is replaced with the empty spaces, and the values is updated. So if the length of the values is 0, then the code has been done, and it will be returning false. So if it's not 1, we'll be checking it later. In the first step, the code will not come over here and we will directly go to the for loops. So in for loop, as we have seen for A3, it will be taking the units of A3. Like we can check over here. Output will be a little larger. So it will be giving, as an example, I'm just saying, so the units of the necessary square. So the 3 units we have discussed in the previous model, right? So these 3 units, in each unit, it will rotate. It will iterate in a list of, this is a list of lists, right? For each and every value, what are the possible values for 1? I mean, this is for 1, right? The first other value. So I'm just saying it. For the possible values for 1 in each and every places will be stored in DP place. So while coming to A3, all the elements have been replaced, right, except 3. So the length of A3 is 1. So we need to remove all the the value 3 in piece of A3. So I'm storing that value in D2. So D2 contains 3, and again I'm calling the eliminate function and eliminating 3 value from the pairs of A3. So the first step is the first step in the constraint propagation has been done in this ellipse. And the second step, if a unit has only one possible value, one possible place for a value, then we just directly put the value over there. So it is done over here. So if the length is 1, then we are directly assigning that, taking that from that values, and in that list the element we are sending to the assign function, and assign function will be placing the element over there. So in the final step we will be returning a false. So in the final output we'll be returning the values, and again in the return values we'll be having the actual grid with 4, 8, 3, 9, 2, 1, 6, 5, 7, 9, 6, 7 in that way. And now I'm sending that grid value to the display function, which I have called in the beginning, and it's just printing the grid in a very understandable pseudocode manner. This is the output which I have got during the display function. And the main problem with this code is, see, for example, by taking the example like this as a simple puzzle example, the code is done easily. We have only one predicted possible value for each square. But for some complex pseudocodes like this example, the grid 2, which present over here, the display will be in fact like this. See, for A2 the possible values can be 1, 6, 7, 9. For A3 it 1, 2, 6, 7, 9. For C3 it's 1, 2, 5, 6, 8, 9. So these many possible values can be present in each and every square. So we need to simplify the code in such a way that for each and every complex problem the output should be present in this way. So we will see that in the later videos. Thank you.